Okay, so it's 1 o'clock Central Europe time to start. First of all, thank you so much for being with us today, and welcome to all of you to this PIARC webinar on electric road systems, the first of a series, and this one is dedicated to technology assessment. I will do a brief introduction to the webinar before passing the microphone to the speakers. So first of all, a few reminders. Please switch on your camera and your microphone, and I would invite all of you to do it right now. You can ask questions in the chat at any time, but we will take them, all of them, at the end. There's a lot of things going in the chat. There is greetings, and that's very much welcome. There may be questions, issues, other stuff. So when you want to make a question, please start by question 2 and name the speaker. Okay, that would be very helpful. We have a lot of people. So far we had 177, but almost 500 register. So we expect a lot of people today. Please keep in mind we will have a limited time for questions and answers. It's 30 minutes. So if you see similar questions of what you have you would like to ask, please restrain for asking. And one tip, please, we invite you to close the window when the presentations are on so you can see them fully. We also invite you to rename yourself. That will help us in case we have issues with trolls, let's say it. And it will also help us to assess who participated to this meeting. And at the same time, people can easily chat with you, knowing who you are during the meeting. This webinar is going to be recorded and we will be made available over the next days in PIARC website and our PIARC YouTube channel. For you not to be surprised, we will have a live polls during the webinar. So we will have 4 questions. Alexandra Cybulska, technical advisor in PIARC, will be dealing with that. So we, sorry for that. So we thank you in advance for your cooperation. This is our program today. I'm doing this welcome. Then I will do a very short institutional presentation of PIARC, and then I will hand over the screen to the speakers. First one, Jan Pedersen, the chair of the PIARC Task Force 2.2 dedicated to electric road systems. He will present the objectives of the seminar and the task force. And then Patrick Duprat from Alstom will present us APS for roads. Mr. Takamitsu Tajima from Honda will present high-speed and high-power conductive electric road systems. Josefin Aderell from EVIAS, Sweden, will present us electric roads enabling the transition to e-mobility and future transportation needs. Patrick Ackerman, together with Augustin Bourreau from Siemens and from NG, they will present catenary for sustainable heavy road transport. Karin Evinhurd, from the CEO from Elon Road in Sweden, will present transforming the future of mobility with electric road systems. And Oren Esser, the CEO and co-founder from Electron, will present it commercializing wireless electric road systems. And then we will have a Q&A and a debate, and you are very much invited to take part into it and to say your questions and answers. Please, if you can switch out your microphone. Yeah, thank you. With all the speakers, plus some PIARC Task Force representatives. And then Jan will close the meeting. So 3 slides to present PIARC, no more than that, I promise. First of all, what is PIARC? PIARC is the new name for the World Road Association. It's an old organization founded in 1909 as a non-profit, non-political association. Our goal is to organize exchange of knowledge on all matters related to road and road transport. We have currently 125 member countries, as well as regions members, groups, companies, we call it collective members, and individuals members. And it is the first global forum for exchange of knowledge, policy, and practice on roads and road transport. We have 4 key missions, being a leading international forum for the analysis and discussion of the whole spectrum of transport issues related to road and road transport. Identify, develop, and disseminate good practices and give a better access to international information, as we are doing today. We are very keen in considering our activities countries with developing economies and economies in transition. And we aim to design, produce, and promote efficient tools for decision-making in all matters related to road and road transport. How do we do that? Well, thanks to the 1,200 experts mobilized in our 22 technical committees and task forces. And here's my last slide, and that's the representation of our strategic plan 2023. Here we have all the technical committees and the task forces. They are structured in 4 strategic themes. And as you see in the strategic theme 2, mobility, we have this task force 2.2 electric road systems, who is in charge of the webinar today. And with that, I pass the microphone to the chair of this task force, Jan Pedersen, please.
Thank you, Miguel. Thank you for this introduction. And now I will share my screen. Also, we start with that. And Miguel, can you please say if you see my screen?
We see your screen, not in presentation mode yet.
Yes, hopefully soon. Maybe now?
Yes, now, but now we see the next slide. So maybe it's better you just go back to the previous one as you wish.
Oh, sorry. Oh, sorry, something happened. Maybe we have to go by this. Anyway, I would also like to welcome everyone to this webinar regarding electrified road systems. And I'm really happy to hear that you say, Miguel, that we maybe be 500 participants for this webinar. I mean, this really proves that there is big interest regarding this topic. And today we will have the opportunity to listen to a number of representatives from the Ers electric road system industries. And of course, there are more industries across the world that are working with these issues, but we will have a number of examples presented for us. And of course, electrified road system, but let's also talk a bit about electrification of the road transport. Electric road system, I would say, is one example of how to electrify the road transport. And when we talk about electric road system, we talk about a road supplemented with an electrical installation intended for the transmission of electrical energy to vehicles during travel. And we talk then about dynamic charging of vehicles while they're moving. But of course, electric road system needs to interact with other smart systems for electrification. For instance, battery vehicles with static fast charging, and also hydrogen that feeds fuel cells, for instance, also very interesting example of electrification of the road transports. But why do we talk about electrification and ERS? ERS is, of course, a shortening for electrified road system. We are all aware about the Paris Agreement, that we need to reduce the climate gases. And of course, the transport sector is one of those contributors of CO2 gases. So we need to address these issues for the transport sector also. And we need to free the transport sector from fossil fuels. And we think that electrification is a solution for tomorrow's fossil-free transport system. And electrified road system could be one possible solution for diminishing the carbon footprint from road mode transports and passengers' cars. And of course, road transport, we have discussed this in the task force. We think it always will be needed. And in many countries across the world, we also see that the traffic amount is constantly increasing. So we think that we probably need a different kind of solutions. We talk about electric roads, battery static charging, hydrogens and fuel cells and so on, but also biofuels. And of course, we also need to work with increasing the efficiency within the transport system. I mean, can we reduce the transport? Can we reduce the transport of goods? Can we also move goods from rail system and to maritime system and so on? We think all tricks will be needed to reach the goal by 2050, according to the Paris Agreement. So we are here today now to talk about electrified road systems. And we know there is a big interest regarding this topic. And of course, the webinar today shows that too. This is a map from the previous report that we performed within PIARC from 2017 that shows the countries that are working with ERS road system. Of course, if we should update this map today, we will probably have a number of more countries with brightful colors. As I said, we will hear examples from different kind of technologies today. And when we talk about electrified roads, I think you need to switch off the microphone.
Please switch on the microphone. Switch off the microphone. Thank you.
When we talk about electrified road system within the task force within PIARC, we talk about 3 different kind of type techniques. And on this slide, you can see those 3 different kind of type techniques. To the left, you see 2 slides that show inductive techniques, wireless transferring of energy between the system and the vehicles. In the middle, you can see 4 pictures of example of techniques where you take the energy from beneath or from the side to feed the vehicles. And to the right, you can see the system where you take the energy from above by using a catenary system, and you have a pantograph above on the vehicles. So these are 3 different kind of type techniques, and we will hear examples today from all of these 3 different kind of types techniques. PIARC launched this task force last year, and the purpose with this task force is to share knowledge and experience within this area, to examine different kind of national research and development projects, as well as from demonstrators, and finding from these activities will be presented and spread as today, but also later on PIARC website. So we want to promote knowledge within this field of electrified road systems. And apart from what we're going to talk today about technologies, we will also review potential stakeholders. Then we talk about, for instance, vehicle manufacturers, power supply, grid owners, but also transport administration, road owners, etc. Because we want to also analyze business models, interoperability issues, national strategies and policy. And finally, we will try to present possible recommendations for how to accelerate implementation of ERS and also future international cooperation of ERS, and also the role of PIARC within this area. So by that, I'm really looking forward to this webinar today. And I think now, Miguel, it is time to start the webinar. And I therefore hand over the word to you, Miguel, to guide us through this webinar today. Thank you.
Thank you very much, Ian, for this presentation and for the introduction. Actually, we'll pass the microphone to Alexandra Cybulska, PIARC Technical Advisor for Events Strategic Organization, that will facilitate the discussion and the presentations. So please, Alexandra, the floor is yours.
Thank you, Miguel. Thank you for this introduction. I'm really honored that I can today lead this event and help you to go through all the presentations and all our speakers that we have today. We have already more than 200 participants, so that's perfect. It shows your interest in the topic. So for that reason, I would like to ask you to respond to our first poll that we have for you today. I will just launch the poll for you, and I hope it will be visible. And please respond it to this poll. We'll open it like for a minute. When you will choose the right response, please submit it. So it's not only the clicking, but also submitting your response. So we will leave this poll open for few moments for all of you, so you will have a chance to respond. And in the same time, using this opportunity, I would like to present our next speaker that we will have today. Mr. Patrick Duprat from Ers Solutions. He is from Alstom. He's Ers Solutions Manager and coming from France. Patrick, do you hear us? Do we have you here?
Yes, I hear you.
Perfect. You can turn on your video also.
Okay.
It will be visible. Perfect. And please share your screen with your presentation.
Okay.
I'm just reminding about the pool that we have. We are still responding on that, so that's excellent. Please respond and we'll have it open for a few more seconds. Perfect, thank you very much. I will end the polling. And the floor is yours, Patrick. Please remember about this 20 minutes that we have today. Thank you.
Thank you, Alexandra. Good afternoon, everybody. First, I would like to thank you, PIARC, to give us the opportunity to present our electric road systems. Do you still see my screen?
Yes, we can see your screen, but
I have just an issue.
You're just on the
Patrick, je crois que tu dois juste, en fait, tu es dans la dernière diapo. Donc, si tu sors et tu remontes dans la première diapo, ça devrait mieux marcher. Voilà. Tu peux passer comme ça ou... Ouais, voilà, c'est bon.
Oui, maintenant ça marche, merci.
Sorry for that. So in this presentation, I will first introduce the different Ers solutions. Then I will show you a proof of concept we have done in Sweden. After, I will detail our APS for road solutions we are developing in Alstom, and I will conclude. So, as Jan said, we have three categories of Ers solutions. The conductive one, via overhead catenary lines, where the current is collected via pantograph located on the roof of the vehicle. The conductive solutions via ground-based power rail, where the current is collected via a pickup installed underneath the vehicles. And the inductive solutions using coils integrated in the roadway, and where the power is collected by receiver plates located underneath the vehicle. If you look at the pros and the cons of each group of solutions, the advantages of the catenary system are that it does not impact the roadway, and it provides an efficient power transfer. But it has some cons, like high visual impact. The fact it is usable only by heavy-duty trucks, and it creates obstacles over and alongside the road. The main advantages of the solutions with ground-based power rail are an efficient transmission of electricity that enables vehicles to be propelled and their battery to be recharged in the same time. And the fact it is usable by all types of vehicles. The cons are the fact that the road surface requires modification during the installations, and the fact the conductive segments are directly accessible on the road. For the inductive solutions, the advantages are mainly the fact there is no visual impact, and it is usable by all types of vehicles, even if the power transferred is not enough for trucks' need. The main drawbacks for these solutions are the installations that requires the road surface to be removed and then to be replaced, with later also a risk of pavement failure due to the buried materials. To be noticed also a low lateral tolerance, the generation of magnetic fields, and a low to medium power transfer. Even if in Alstom we have all the skills necessary to develop catenary solutions as a leading company in the rail industry, or an inductive solutions with, among other things, the recent acquisition of Bombardier, which was the most advanced entity in this field. We have chosen to develop the conductive ground-based solutions because it is the one that best meets the needs for the electric roads. In addition, Alstom is a world leader in ground-based power supply systems, with the following solutions under development or already in service proven, on which we have already demonstrated the safety and the efficiency of this type of solutions. So we have developed dynamic feeding systems like the APS for tramway, in operation since soon 20 years, with more than 50 million kilometers run with this system. It is this system we are developing now for road applications. But we are also developing stationary recharging systems for tramway again. For instance, in Nice, the supercapacitor on the roof of the tramway are recharged at stops in a few seconds with a power transfer up to 1.2 megawatt. We are also developing the same technology for buses, where we will be able to recharge with a power transfer up to 800 kilowatts. It is for our experience and capabilities that Volvo Trucks asked us in 2011 to participate in a research and development project on dynamic charging. The objective was to demonstrate the feasibility and the efficiency of ground-based conductive power supplies for heavy-duty trucks. In 2012, we built a test track on Volvo Test Center using our APS technology, and Volvo Trucks has developed the onboard parts. All the tests planned on this project have been passed successfully. On this project, as I said, Volvo Trucks demonstrated also the integration feasibility of ERS prototypes at this level component on a normal size structure, although it was a hybrid truck with two powertrains. You can see the current collector device installed in the middle of the tractor, and which was equipped with a lateral positioning system able to move plus minus half a meter from the center with an accuracy of 1.5 centimeter. Here is a short video of the trucks in operation on the test track. We started with a test truck, and you can see here the accuracy of the lateral positioning system. The test has been carried out at different speed, up to 90 kph, in different railway conditions. Here you see in slow motion the collector shoes lowering on the conductor rail, one for the power supply and one for the return current. Since this proof of concept, we have developed the APS for road system for road applications. New components like the Ers feeding track have been developed to fully answering road needs. It will be installed in the axis of the slow lane with the conductor segment on the surface. You can see here in red one of the power supply segments. It is energized only when the current collector shoes in operations are arriving on it, and it will be de-energized as soon as the current collector shoes will leave it. As you can see, a part of the power supply segment, 10.6 meters long, can be energized outside the vehicle. This could be dangerous, even if the probability to have pedestrian on highway is very low. So, for safety reasons, this segment will be energized only if the vehicle is driving over a minimum speed limit, we fix at this time at 30 kph, and if there is no obstacle in front of the truck. It could be detected either by the driver or by smart sensor installed in the vehicle. These Ers segments are safely energized by power boxes buried along the road. And in the substation, we have a key component like a very high-speed circuit breaker able to open in less than 2 milliseconds. On the top, we have a supervision system to control and monitor all the electronic devices in the substation and along the road. This supervision system can be interfaced with a road operation control center, as we are doing on tramway system. Now let's make a focus on the Ers feeding track, the trickiest part, I would say, or at least the one on which we have the more questions. The objective was to develop a very robust solutions, having no impact on the road and easy to install. And shown on the diagram and the photo, the Ers track is integrated in an optimized groove made in the axis of the slow lane, with a rubber part glued to the pavement. And here on the right, you can see a test track made with these solutions. The robustness have been demonstrated, and a lot of tests have been carried out to select, then to validate a good solutions. All the tests have been carried out by the Université Gustave Eiffel in France, previously called IFTA. With simulation tools, and then we'll test on small samples, was validated the gluing, the rotting, and the thermal cycling from -20 to 60 degrees. Then we carried out also fatigue testing using the FABAC machine with its wheels loaded at 6.5 tons, which continuously cross an Ers track. The Ers feeding track is now fully validated. We use the same approach for the skid resistance. We first simulations and test on small samples, and then wheel testing on a test track built for this purpose. All the tests have been carried out with different vehicles on the test track. And for instance, the moto you see on the right picture cross the Ers track at speed up to 180 kph. It was the maximum reachable on this place. The Ers feeding track we are proposing is answering all the security, comfort, and skid resistance requirements for a safe use on highway. On the same way, for the winter maintenance, we have built another test track in the Vosges mountain. The objective was to see the effect on the Ers track and the surrounding pavement also of freezing, throwing, rain, snow, salt, heat, etc. We wanted also to monitoring the effect of the winter maintenance with the use of snowplow as shown on the video on the right part. And since 2 winters, the CEREMA Institute is in charge to monitor and survey these activities and has noticed no negative point. In addition, current leakage measurements have been done, showing that the salt and the brine spread on the road will not affect the operation of the electric road system. You see here, after the snowplow, the rails are directly accessible, so we can transfer current. Here are now some operating performance data. Our system is now designed for 400 kilowatts power transfer, even if we can provide much more with these solutions. This would be enough versus the need, and it will help to optimize the length of road to be equipped. The power transfer is still 97%. On highway, we plan to operate between 30 and 90 kph. With this technology, we are able to power supply all types of vehicles, from the heaviest one to the lighter, like the car if needed. In terms of maintenance, for the feeding track, it will be limited to the conductive segment on the top to be replaced when they are worn. It is estimated after 6 million vehicle passage. The power switching boxes are designed with a high level of MTBF, but in case of failure, they can be quickly replaced without any impact on the operations. When the road pavement needs to be replaced, it can be done without impact on the Ers track, feeding track that stay in place. On the vehicle side, the only mechanical maintenance plan will be the replacement of the collector shoes when they are worn, estimated every 60,000 kilometers according to our railway experience. Here is our roadmap for these solutions for the experimentations and the deployment of ARPS for road. After the proof of concept made in Sweden with the heavy duty truck, we plan now in the next phase a test track project in France. We plan to do with the Institute VDECOM and French partners. The objective will be to fully validate the system and to demonstrate it with a medium duty truck and a van. Then the next steps will be an experimentation on highway sections somewhere in France with the same vehicles, but with other one, if possible, to fully demonstrate the interoperability between the vehicles. Then we will be ready to for pilot project or large deployment if our solution has been selected to electrify the road across Europe. In terms of standardizations, some actions are ongoing at European level. In Sensenec, in Technical Committee 9X, in the Working Group 30, we are preparing a technical specifications about the current collector device for ground feeding system. And in October last year, the European Commission issued a new standardization request for the Ers systems, including one for the dynamic power supply through conductive rails. To conclude, the APS for road systems based on a service-proven solutions is the only electric road system providing a robust, safe, and efficient power supplies on highways for all types of vehicles. This technical solution is the easiest to install and maintain in terms of cost and in time. Due to, for instance, reduced civil works, we will be able to install up to half a kilometer by day without stopping the operation on the highway. And combining interoperability with a high level of power transfer, the APS for road solutions will offer the most profitable electric road system to decarbonize the road transport. Thank you very much for your attention.
Thank you very much. But you can stop sharing your screen. It's the red button on the top of your screen. Just stop share. Yeah, perfectly. So thank you very much once again for a very good presentation and overview of your actions that you've taken in last years. I think that it's very interesting to all of us, especially with this aspect of the winter maintenance, especially with the winter that we have this year, which is quite severe. So it's very good to know. So please, I'm asking all our participants, we have 220 participants this time. So please, if you have any questions, doubts, I really encourage you to ask those questions to our speaker. Please put your question in the chat. After all the presentations, we'll have Q&A session. Please remember, when you will start your question, please start with the name of the speaker to whom you are directing your question. So that will help us on the end to lead the Q&A quite smoothly with all the questions and speakers that we will have. Perfect. So now we can go further to our next speaker. And our next speaker today is Mr. Takamisu Tajima, Chief Engineer, General Project Leader for Ers Honda Japan. Yes, we can see you already. So please start sharing your screen with your presentation.
Just a moment, please.
It's okay. And the full mode. Yeah, that's perfect. Yep. The floor is yours.
Thank you, Alexandra. And thank you very much for inviting me. Hello, everyone. I'm Takamitsu Tajima of Honda R&D. My presentation today will concern high-speed and high-power conductive ERS. My presentation will follow the other shown here. I will begin by discussing the background and the aim of our research in order to provide an overview. Looking first at the background to our research, the achievement of zero emission during vehicle operation will be an important factor in our efforts towards the realization of zero CO2 societies. Vehicles that operate using motor power alone and do not use generators employing fossil fuel as a source of energy will be essential to achievement of this goal. We therefore believe that evolution of the EV and the FCV will be a key focus. However, the EV presents a number of serious issues, the main being cruising range, charging, and a decline in dynamic performance due to increase vehicle weight. We believe that there are broadly two ways to address these EV-related issues. One is to boost battery performance or to increase the number of batteries fitted in the vehicles. The other is supply power to or charge the vehicles while they are in operation. That is to realize ERS. The figure on the left shows the relationship between battery capacity and cruising range. If a car travels 500 kilometers, it needs a battery capacity of approximately 100 kilowatt-hours. This graph on the right is approximately the number of EVs produced. The amount of waste battery that results from this is 5 million tons in 2031. They are likely to end up becoming land pollution. This is particularly the case when automobile manufacturers go on increase their EV production. It is said that development of cobalt will occur in approximately 10 years and lithium in approximately 15 years. Just a moment. Now, I would like to describe another approach, which is ERS. This means that battery installation can be reduced to 1/10 the amount. In other words, the production of lithium-ion batteries can be continued 10 times longer. This was the background to our development of the high-power ERS that I will be discussing today. The aim of our development was to realize an unlimited driving range for EVs by charging the vehicle using large amounts of power while they are in operation. The realization of unlimited driving range in this way would offer users the freedom to operate the vehicle and to stop and get out just they please, without the constraint imposed by the necessity of charging. Today, I will be discussing ERS at 150 kilometers per hour using a power of 450 kilowatts, a DC voltage of 750 volts, and a current of 600 ampere. We consider the power supply from in-load at the first stage. In the wires type, there are safety issues related to electromagnetic noise. In both types, there are issues with falling matter positioning and load maintenance. This table compares different methods of ERS. Wires type and conductive type charging methods are compared. Based on these considerations, we decided that a conductive type system that supplies power from the side would represent the most effective system. This slide shows the contact type system. The previous contact type was a sliding plate type using in railways, LRTs, and buses. Our system is a new principle that is considered from the automotive society and is a rotating roller type. This method is applied from passenger cars to heavy-duty trucks. Here we see an overview of the ERS. The system compares ERS and a dynamic charging EV. The infrastructure consists of a high-capacity storage battery and ERS range. The vehicle is provided with a power collection unit, a dynamic charger, and instantaneous charging battery pack, and a standard EV system. Next, I will consider the associated infrastructure. The ERS lane can be created by mounting trolley wires on an existing guardrail. The screen shows a magnified view of positive and negative trolley wires attached to guardrail in a V-shaped configuration. Protective covers made up of insulators and insulating materials are fitted around the trolley wires. Simply by pushing from the side against the trolley wires in the V-shaped arrangement, the power collection unit's height is centered and the rollers made the desired contact. We have applied Japanese railway safety standards. Let's look at this system overview in greater detail. The pink section here presents technologies that had not previously existed. DC power is supplied to the ERS LAN from the high-capacity storage battery. The ERS LAN supplies DC power to the vehicle. On the vehicle side, the power is collected by the power collection unit and provided to operating motor and batteries simultaneously by the dynamic charger. Each of these systems is controlled by an integrated control ECU. Next, I would like to talk about the simulation result. This slide shows an overview of the simulations that were done. One section of expressway in Japan was chosen as a simulation course. The area distance is approximately 100 kilometers, and the difference in elevation is 380 meters. This table shows Ers Simulation Specifications. The simulation conducted here covers the case of passenger cars and heavy-duty trucks driving an expressway and carrying out dynamic charging. The passenger vehicle has a weight of 1.4 tons and cruising speed of 100 kilometers per hour and 200 kilometers per hour. The heavy-duty truck has a weight of 25 tons, a maximum power of 300 kilowatts, and a cruising speed of 80 kilometers per hour. The energy consumption of all auxiliary equipment was also included in the total. The ERS power was set as 450 kilowatts. This table shows a summary of the various simulation results. These are the conditions that apply. In the case of a passenger vehicle class EV traveling at 100 kilometers per hour on an expressway, it is charged over 2.8 kilometers in the section, 53 kilometers long. In the case of a heavy-duty truck that travels at 80 kilometers per hour, it is charged over 15.8 kilometers. The vehicle was to have batteries with at least approximately 100 kilowatt-hour installed. This figure of 100 kilowatt-hour is same battery capacity as a large passenger EV, Tesla Model S. Let's look now at the results of tests of the system. To continue, I will look at our prototype vehicles. We created 4 prototype models. Next, I will consider the associated infrastructure. We are carrying out a running test. Type 1 is charged using a power of 100 kilowatts at a DC voltage of 375 volts and a current of 300 ampere. Power can be supplied to the vehicle at a vehicle speed of 14 kilometers per hour. The vehicle enters, The vehicle entered the ERS lane and the power collection unit makes contact with the conductor rails. When this contact is made, the tip of the power collection unit detects the voltage and the ERS begins to function, charging the vehicle. When charging is complete, the driver is able to freely resume the desired driving pattern. Next, I will talk about the Type 2 prototype. This is a Type 2 prototype. This vehicle has 300 kilowatts of power, the same as a heavy-duty truck. Type 2 is able to charge using a power of 180 kilowatts at a DC voltage of 600 volts and a current of 300 ampere at a vehicle speed of 155 kilometers per hour. By optimizing the contact pressure and the dynamic pressure control, we were able to considerably reduce arcing. Out these results shows we are able to considerably suppress the arcing. Today, however, our Type 3 and Type 4 prototype vehicle will be the main focus. Type 3 and Type 4 are able to charge using a power of 450 kilowatts at a DC voltage of 750 volts and a current of 600 ampere at a vehicle speed of 200 kilometers per hour. The ERS lane is 385 meters long. I will now discuss Type 3 in greater detail. This is a Type 3. These are the main system making up the dynamic pressure. This video shows the power of 400. The video on the lower is normal. The video on the top is dynamic pressure. This way, we are able to drive for unlimited range while using maximum power. Here we see the results of preliminary verification tests conducted at low vehicle speeds. The horizontal axis shows charging distance and the vertical axis shows voltage, current, power, and vehicle speed. The results show the vehicle being charged at a speed of 60 kilometers per hour using a power of 450 kilowatts. Next, the results of charging test at a speed of 150 kilometers per hour using 450 kilowatts. By optimizing the contact pressure and the dynamic charger control, we are able to considerably reduce arcing as shown here. The power collection unit extends and retracts approximately 1 meter in the lateral direction, and we have also incorporated the lane keep assist system that we employ in our market vehicle, which detects the white line on the road. I will now considerably future outlook for this technology. The goals of our research is the promotion of substitution of internal combustion engine vehicle and realization of carbon-free society by ERS. I'd like to establish the basic technology and aim for real social justice to develop and put into practical use the technology of race and the general society. Here we see an image of the future of this technology. In the future, high-capacity storage batteries will be charged using recycled energy and will supply this energy to the ERS charging lanes. In addition, multiple vehicles will be able to dynamically charge in the same lane. This figure shows a Honda ERS car lineup. We will make heavy-duty trucks and very small, super small car. This is a stationary charging system. Rollers placed on the infrastructure side rotate to radiate heat. That brings me to my conclusion. Allow me to sum up my presentation. Infrastructure and vehicle system are able to realize ultra-high power and high vehicle speed ERS were developed. Simulations of ERS reduce the conditions for realized automated driving distance for EVs using ERS. In the future, we intended to continue effort to further increase vehicle lineup, boost reliability and safety of the ERS, attempting to realize practical application of the system on early stage in increasing its power. We are making many types car, and now we are making now next generation ER system, next mobility and compact ERS. Coming next month, I will show you a new system next month, 2 weeks later. Thank you very much for your attention.
Thank you very much, Mr. Tajima. You can stop sharing your screen. It's near the red button on the top. Perfect. Thank you very much once again. And I can see that there are already questions to you in our chat mode. I have a question to you directly, because I know that you are in Japan and it's quite late for you. Will you be able to stay with us till the end to respond to all the questions, or we should rather send to you by email, or and you respond later on? Because it will take still 2 hours to go to Q&A session. So will you stay with us, or you prefer to do this other way around?
I will stay.
Excellent. Thank you.
Yeah.
Thank you very much.
Okay.
Thank you that you
problem.
can spend this long evening with us. Thank you once again for your presentation. And now we can. Thank you. We can go to our next speaker. And our next speaker is Josefin Aderell, CEO of Ers Sweden. Josefin, we can already see you. Please turn on your presentation if it's possible.
Yes. So can you see my screen now?
Yes, we can see it. Please turn on your full mode. Yes.
This one works.
That's excellent. Thank you. The floor is yours.
Thank you. So thank you very much for inviting me to this very interesting seminar. I've been on this amazing journey to introduce electric vehicles on the market for over a decade now, working with different types of charging solutions, such as battery swap stations, to building a network of super fast charging stations. And just before joining Ers, I launched a free floating car sharing service with fully electric vehicles on the market in Stockholm. So I hope today that I will be able to give you not only technical details about Ers and where we are standing, but also put that into context within the society, and also how this should work for the end users, i.e. you and I and all the other ones in the society. Hence my title, Enabling the Transition to E-Mobility and Future Transportation Needs. So we've heard Monsieur Duprat, and we also heard Tajima-san explaining the advantages of electric road systems and also electric vehicles. But just to come back to this, so we all know that electric vehicles are the key technology to reduce air pollution and greenhouse gas emissions. However, there are still challenges for a transition to e-mobility. So last year was a fantastic year in 2020 for the sales of electric vehicles, but we still have 99% left to go when it comes to the global car stock or vehicle stock market. So we still have a lot of vehicles that will be electrified within the years to come. And with that, we need to also think about how should this infrastructure work. So we're going from an immature market where people are worried about the range. We still have that driving range over to a charging anxiety. So looking at driving range and big heavy batteries, especially when we look at bigger transportations and bigger trucks, how do we make sure to have a long driving range and also combine that with batteries? What about the load capacity, for example? That could be one issue. And regarding charging, so if we have fixed charging stations, what about the recharging time? How long time does it take to recharge? How do we solve peaks during holidays? If we have bigger fast charging stations, there will be a lot of power that needs to come out from that specific location. How do we make sure to get enough power to that station? Is the grid big enough, or do we need to look at the grid system in its all? And also when working with shared vehicles and especially when we go over to autonomous vehicles, how do we make sure that we have an occupancy rate for these vehicles that are optimized? So how can we make sure that they can be recharged and used in an optimal way? And also when it comes to charging infrastructure, where should we place it and is it safe? So when I worked with these super fast charging stations, one question that we always had in mind was, if I'm a mother with 2 children and I arrive at this charging station at 11 o'clock in the evening, is it lighted? Is it uplighted? Can my child go to a bathroom? Is it safe for me to stay there and recharge my car for 15 minutes, for example? So all these questions needs to be put into consideration when looking at building a charging infrastructure. And I'm saying this because there are some debates whether we should only be working with fast charging stations or if we only should work with electric road systems. And I think that electric road system is a part of the society and it has its place within the society. So we think that electric road system is the backbone of tomorrow's charging infrastructure. We see that this has great advantages because vehicle can be charged while moving, saving both time and parking space. And it's also preparing for the future for shared and autonomous vehicles, since there are no stopover time needed. And looking at from Avaya's perspective, we look at it as a whole ecosystem. So you will have the electrified road as that backbone, but we also have the station-based charging solutions that will still, during a transition period before we arrive to fully autonomous vehicles, we will still have people owning their private car or having the need to have these ones parked from time to time. And there we see that the same system can be used for station-based charging. We also have specific industries with specific needs, taking the mining industry, for example, where it's not convenient to put a road as we see on the road, but we can use the same system and we put it upside down and put it in the roof instead. And then we have a system for mining industry. We also look at how will we use the same system, how can we optimize it for harbors, etc. So when we look at it from an Avaya's perspective and looking at our electric road system, we've seen it not only as an electric road, but as a full ecosystem for charging and for making the transition over to e-mobility the most efficient as possible. But coming to our road charging system, we have a conductive road charging system because we see that that's very cost efficient and it gives a cost efficient power supply through the conductive rails. It works for all type of vehicles. And I think this is very, very important to emphasize, especially when moving over to shared and autonomous vehicles, as mentioned before. We can make our system works for heavy trucks and buses to smaller cars, and we can deliver up to kilowatt DC. That's what we're testing right now. It's possible to charge up to 5 times numbers of kilometers driven, which means that only 20% of the main roads need to be electrified. And this is very good when you're planning for an infrastructure within a country or in a society. You can start with the roads that already have power easily to be in that specific location. So if you already have the grid built up, you can start with that. And then you slowly can build up. And we can also adapt. So we can go from high from 800 kilowatt and we can go down to lower kilowatt delivered. And it will also be different for different types of vehicles. Our technology is a safe and proven technology. We started in 2009 already, and we've been doing extensive testing since 2012. We have a test track where we test multiple times a week. And we also have a demonstration road on a public road to Kilometer road since 2017. So now we're on our third winter. Last year was not that cold in Sweden, but still this year has been quite good for that. A lot of patents, patent families, so that's fine. Something else that I would like to highlight is also that when we look at this system, we will have to make sure that it's cost efficient for the society to implement and that it's easy for the society to have as one part of the transition to mobility. But we also have to look at it from the user perspective. How can we make these chargers that are on the vehicles, on the trucks and on the passenger cars affordable for everyone? So that you can have it as an add-on on your car or on your truck and still see it as a good investment when you're traveling a long time. So that is something we're looking at right now to make sure that once we have the technology, once we have the roads installed, it should also be something that you can see as a return of investment if you have a transport company, for example. Safety is also something that is very important. The rail is very safe itself. We have the conductors deep down in the narrow slot. So you can see I tried to put my fingers down, that didn't work. And the upper steel of the rail is grounded. We have mastic asphalt on the top. You can bicycle on it, that's not an issue. We have sections that are electrified. So we have 50-meter section electrified at a time. So if you were to find something very thin to put down in the rail, at the same time as there is a truck entering this 50-meter section, you will be hit by the truck before you can get electric shock, if ever you manage to get an electric shock, because we have different safety systems that would turn off the power. The rail is also designed so that the smallest bike, racing bike, cannot slip down into the track. And there is no dangerous voltage on the road. We have tried to fill it with conductive salt water and measure it, and that works perfectly fine. So just to show you, this was a couple of days ago. So it works perfectly fine also in winter time. Let's see if I can move over. And as I mentioned before, we also have other charging systems. So we have developed a specific system, or we are actually currently developing a specific system for mining and quarrying industry. That is a joint venture with an Australian company that is specialized within robotics and different mining solutions. We use the same technology as we have. So we take up the rail, we put it up in the ceiling, and then we make it possible to use it within the mining industry. We're also working to finalize a station-based charging solution. We then take a square out of the road, so to say, with the rail, and that can then be used for any type of vehicle as a station-based charging solution. And we see that suitable at end stations for buses or a parking area. And the goal is to have that delivered at the same price as a regular fast charging station. So the most important thing is for us, we know that we have a technique that has been proven, that has been tested, that has been up and running for both in winter time and also in warm summers. We actually had a few of them in Sweden, although it's difficult to believe. And we now see that we need to take this into the society and to put it on the market. Hence, we need to think about all the details and all the partners that we need to have to be able to do this. And we also, as I mentioned, have to think about how this will affect the end user. So same price as a regular fast charging station will be the ambition for when we launch the station-based charging solution. And that was it for me. So I was quite quick today. Thank you.
Thank you very much for your presentation. That was indeed very interesting to see how we can use this infrastructure that we can have and what we can, how we can change our cities to be more convenient for our future. You can stop sharing your screen so that we will come back to, yeah, perfect. Thank you very much once again. I remind you all about the possibility of asking questions. So please go to the chat and just write down your question with the marking to whom you're addressing your question. So that would be the easiest way for us later on to lead this Q&A session. We have also questions regarding the recording. Yes, this event is recorded, and then in upcoming days we will publish it on our PIARC website as well as on the YouTube channel of the PIARC. So you can always come back to this webinar and to all the presentations that are very interesting today. Going further in our agenda, now I would like to ask Patrick Ackermann, head of the e-highway business development, Siemens Germany, and he will share his presentation with Augustin Barrow, head of business development, Ers Solutions, and he's based in Austria. Can we hear each other?
I can hear you. Can you hear me?
Yes, Patrick, you can turn on your camera, yes, and Augustin, I can see you. And I can hear you. So for both of you, I will just.
I still cannot see how I look. So I hope you see me.
Yeah, I can perfectly see you, and I will just share the presentations for you.
So thank you very much for the invitation. So we were asked to give a joint presentation from our two companies. And we thought we would give a brief outline of the presentation that we wanted to present. If you could go to the next slide then, please. Alexandra, there. So we wanted to share our introduction, who we are, and our vision for electric road systems with catenary. And then we wanted to outline the thoughts we have on technology assessment. We know that this task force is looking into different technologies, and then we wanted to ground it in what problem do we want the electric road systems to solve, and how can we assess an electric road system on that challenge. So is it technically feasible? Is it easy to implement at scale? And can it attract users? And if you go to the next slide, please. So our companies might be known, but just to emphasize the point a little bit. So Siemens Mobility is where I work, which is the transportation part of Siemens. Siemens is a large company, but also Siemens Mobility in itself is a large company. We have 38,000 employees, and we cover the full spectrum of transportation solutions from high-speed trains to signaling to intelligent traffic solutions, and of course electrification. Yes, to give a flavor of what kind of projects we are able to execute or have signed contracts for. So we are electrifying about 1,300 kilometers of the Danish railway project. I started 5 years ago, have still some 5 years to go. And we recently signed an MOU for a large high-speed rail project in Egypt, which is also a turnkey solution. So with that, I hand over to my co-presenter, Augustin. If we can hear him. Augustin.
Yeah, do you hear me now?
Yeah.
Yeah, that's better. Thank you very much, Patrick. Yeah, I'm very glad to be your co-speaker for today, and thank you very much for the PIARC invitation. Yeah, hello everybody, and so I'm part of Ers Solutions. I'm working within Powerlines Group, so some figures about Ers Solutions on the slide, but just note that our purpose within Ers Solutions is really to act to accelerate the transition towards a carbon neutral economy through reduced energy consumption and more environmentally friendly solutions. We as a group, and I think that it's also like Siemens, but we want to be a kind of pioneer global role, to have this pioneer global role into the decarbonization, and especially into the rail and road transport. And last point is that the Powerlines Group joined NG Group end of 2019, and now together we are now one of the major European market player in rail and road electrification. Maybe next slide. Yeah, and why we are here all together right now is that we think and we are convinced that we are sharing a common vision. There is an urgency to find solutions to decrease the CO2 emission and to find a way to meet the climate goals. So we can see that there is a various range of technical solutions to manage this issue of CO2 emission. And we are convinced that with the clever combination of those technical solutions, we will have a better impact on the CO2 emission. And we just wanted to mention that we are not here to oppose H2 solutions or battery electrical vehicle solutions to ERS. We think that the combination would be the solutions. And that's what we wanted to highlight. And the best demonstration is that you can see that in both companies, within Siemens or within ENGIE, we are working on the other technical solutions and pushing for that. But we'll just focus on the ERS today. Next slide, please. So today, and it was mentioned by the previous speakers, there is a lot of test projects with a few hundreds meters or a few kilometers of test tracks that are existing across the world. But we really wanted to make a focus on the 3 trial projects in Germany that are on open road with the real traffic, meaning that we are talking about solutions that are tested into real conditions. And it's really different to dedicated ERS test track from our point of view. The first project that was delivered by Siemens Mobility was the ELISA project with the federal states of Hesse, close to Frankfurt. And I can say that it was a success. And the best demonstration of that success is that they have been announced in the past week that there will be an extension of 7 kilometers on that track. Then for the next project, we have combined Power Lines and Siemens our strengths. And so we have altogether delivered the project in the Fesch project in the north of Germany, close to Lübeck, for, let's say, 5 kilometers of ERS. And then right now we are working all together on the E-Way BW project. It's an ongoing project close to Baden-Baden that we are delivering together. I think that you can go to the next slide, and if you can go to directly to the video, that will give you a flavor of what is the ELISA project and what is an ERS in real life.
Freight traffic continues to rise on rail and on road. With the ELISA project, Hessen Mobile and Siemens Mobility created the first e-highway in Germany, and with it a new dimension in electric mobility.
Wir haben mit dem Projektstart absolutes Neuland betreten, nämlich eine solche Anlage auf einer sehr hochbelasteten Autobahn im fließenden Verkehr aufzubauen.
Electrification of the highway is an important building block for eco-friendly freight transport and uses 100% renewable energy. Proven technology rethought. The reliable system of supplying power through overhead lines was transferred from the rails to the highway. It combines the efficiency of electrified rail with the flexibility of trucks and leads to a significant reduction in energy consumption without restricting mobility. Trucks can charge their batteries through the overhead lines and therefore also drive fully electric when not on an e-highway. The system is compatible with the existing infrastructure, can be combined with alternative fuels, drive systems, and new transport technologies, and makes a quick payback possible for trucking companies.
Ich bin natürlich sehr froh als Verantwortlicher, dass wir in diesem Projekt es geschafft haben, just in time einen E-Highway zu bauen, der noch der längste, den es momentan weltweit gibt, ist.
With the ELISA project, Hessen Mobile and Siemens Mobility created a flexible solution that is future-proof and can be implemented immediately, making an important contribution to climate protection.
So if we then go back to the presentation, next slide, then you have a little flavor of our capabilities and experiences of implementing electrified roads. Now we wanted to share our thoughts for a technology assessment that is then of interest to the PIARC community. And the first point is, what do we want ERS to do? If you go to the next slide, please. So we believe in a technology with a purpose. We don't want to do research just for research's sake. Of course, that is important, but that's why we have universities. And I think this is a point that also been very well put by Sweden's Trafikverket in their national roadmap for ERS. That say it's important to take steps towards implementation as soon as possible, because there are certain expectations of society on a political system on ERS, and mainly that comes to do with the sustainability aspect. And if we go to that next slide, we believe that the core benefit of electric roads is that it can make heavy road freight sustainable. And why do we say that? Well, we start with the fact that climate change and maybe also the COVID recovery are the biggest challenges that we face now. And I will focus on the climate change, although I think for the COVID recovery, any infrastructure program that would be associated with building out ERS would also be very helpful in both boosting the short-term economic activity, but also putting the economy on a higher productivity level going forward. Within the decarbonization or climate change challenge, of course, there are many other sectors. And we see that the power sector is making good progress if you just look historically, but also if we look at the forecast going forward, there's still a very high optimism about the possibility to decarbonize the power sector. That, of course, won't be easy, but the more difficult you think it will be, the more important it is to use this renewable electricity efficiently, and therefore the high efficiency of the electric road systems plays very much to its advantage. And therefore, because we expect this more available, higher availability of renewable electricity, we see that this path is then something that we can use to decarbonize other sectors, particularly then road transport. And as mentioned by other presenters, battery electric solutions are coming, and stationary charging is something that's already available, especially then for urban road transport, be it with cars in cities or buses. But we also see light commercial vehicles having a very big upswing now in terms of electrification, because they have predictable routes, they have come back to base, they are fairly small. Here we see great progress. And therefore, if you look at the roadmaps, for instance, in Germany, where I'm based, it's very clear that government is aiming for about 10 million battery electric cars within the next 10 years to reach the climate goals. And this is seen as a realistic path also by the industry. So there's a strong push both from governments and the automotive industry for this technology path. We also see it, for instance, if we go to the quote on the next page, in the Trafikverket's report just 2 weeks ago, that they conclude that for electric roads, there's unlikely to be any need for it by passenger cars, because they in practice can address their trips with existing battery capacity. So if you go to the next page again, go forward, please. Then we see that what the vehicle type that really stands out, that's the fourth bullet point, that's the long distance trucks. They are the ones who are still very difficult to decarbonize. They're seen as a hard to abate sector. And there are many people thinking what could be the solutions here, or what combinations of solutions. As Augustin mentioned, we think that there would be a combination of solutions, but there's also clearly a role here for ERS to play. And this also explains a little bit, at least in Germany, I think, why we not only think that there are solutions for cars that are different from the ERS, but also why we think that ERS is unlikely to be used by battery electric vehicles. For instance, if you think about where would we want to put an ERS, we would want to put it on those busy highways where you have lots of traffic, because you want to have high utilization of any ERS infrastructure. And in Germany, that typically means the 3+3 lane highways. And in those highways, then the lane on the right is essentially a truck lane. So where you would build the ERS infrastructure, there you have lots of heavy, big trucks going 80 kilometers an hour. And many people who, when they go in the car, they prefer to not be in that lane. So even if you would install an electric road system there are very few cars that would want to drive much slower and drive with the trucks. They would prefer to be in the other lanes, and sure, they would need then to make a stop every 3 or 4 hours and do a quick charge, but maybe they can combine that with a coffee break, and there's no essential extra cost to them. So we see that there's no need for the cars and light vehicles have other solutions, and they're unlikely to use the electric roads. So the focus really should be on the long distance trucks. And if we look more closely on the long distance trucks, we see that the tractor trucks, they are the workhorses of the transportation system. If you look at the EU numbers, it's about 70% of all the truck emissions that are caused by them. And in Sweden, also from the recent Trafikverket report, 75% of all the transport work in the domestic road freight in Sweden is done by these tractor trucks. So that sets a very clear standard of which vehicle type we're aiming for to solve, what we want to use the ERS for. Next slide, please. So then we go into how can we assess different electric road systems on solving this challenge of decarbonizing the tractor trucks. And then if you go to the next slide, please, again. Then we looked and talked, of course, to the OEMs and the industry. What needs do you have for your vehicles if they were to use the ERS? And then it's very clear there's a power requirement. You cannot have too little. If you have too little power, you cannot even provide traction. And in Sweden, you have heavier trucks than in other countries. You have 60 tons trucks going even higher a little bit. Other countries are keen to also increase the vehicle size and vehicle weight. And if you don't have full electrification of the whole system, you have just a share of the roads electrified, then you need to transfer more power during the journey to also cover those gaps. And maybe you also want to recharge a battery so that when you leave the highway, you can also go on fully electric mode. So there's a need to have about 200 kilowatt of power transfer to the truck. And if we see, as many do see, there are more battery electric trucks coming so far with very limited range, but maybe one can then use a battery truck with a 300 kilowatt hour battery size maybe to go on the highways and then fully recharge that battery truck while they're on the highway. Then you need an even higher power requirement. So there's I would say there's a minimum need of the 200 kilowatt and great upside potential if you can go up to 450 or maybe even 500 kilowatt. Then another requirement is, of course, it needs to work on these public roads, on these public highways. That means at least 100 kilometers an hour. Of course, the trucks should not always go that fast, but this is a practical need in the industry. They also need to be able to flexibly drive within the lane. And they, of course, need to have some clearing over the road. And last but not least, this is a solution that needs to be fitted on these articulated trucks or tractor trucks. And this is not just a challenge for ERS. I think this also explains why the tractor truck dilemma or the challenge is so prevalent, because it's limited space on such a vehicle. And that's a challenge also for battery solutions.
Perdón un momento.
Packing batteries.
No.
The person talking here. And it could also be a challenge. Could someone please mute themselves? Yes. There's also a challenge, say, for hydrogen to find all the space for the hydrogen tanks. So these are aspects that need to be fulfilled. These are must-haves for any electric road solution. Next slide, please. So besides having the technical requirements in place, it's also important to have an ERS solution that can scale quickly enough. And why do we think that time is of the essence? So the most obvious one is, of course, the challenge that we have from climate change, that there's an accumulation of greenhouse gases in the atmosphere. So if we don't start reducing them soon, then the challenge becomes very, very difficult or almost impossible to limit global warming to the Paris Agreement stipulated. But another aspect is politicians know this, so they've already started tying themselves, or at least tying the industry, to some of these goals. And especially the truck manufacturers in the EU and North America have now given a very clear signal from the regulators that they have to deliver solutions that will decarbonize the tractor trucks to a very large extent within this decade. And of course, if ERS is not applied at a critical scale by then the OEMs are very strongly compelled to invest billions in other technologies, even if these technologies would not be the optimal from society because they would be less energy efficient or more costly. And as an example, I found a submission from Volvo Group ahead of the EU regulation, where they calculated that because of the very high fines that are attached and the way you can avoid them by selling any kind of zero-emission vehicle to a certain extent, they estimated that they could reduce their penalties to a very, very high degree. And this number then, to me, one reading is that they will be willing to take a huge loss or even maybe pay someone to buy a zero-emission vehicle in order to avoid the fines. And that cannot be the optimal way to go. So we see that the OEMs will definitely be pushing for solutions, but that might be the optimal one. But if we can now bring out electric roads on large scale, that would be the more economic way going forward. Next slide, please.
Yes. Indeed, Patrick, so we'll hand over. Yeah, that's important to mention that, because I think that we are convinced that we are not talking about solutions that should be ready in 2025 or 2030. I would say it's right now that we need to act. And that's why we have also now looked at the approval process, because if it's a today issue, it's important to analyze the ability to have a quick approval time process of the ERS. And what we can say about that technology of the OCL, I mean, a general benefit of the Ers is that it simply upgrade the existing motorways, meaning that we have practically no new land that are necessary, and it should be an advantage over the different solutions that have been presented. And I mean, it's important also to mention that there is no impact on the road infrastructure, especially for the catenary system. As you can see that you just have to deploy the mast and the cantilever in the catenary system. It was mentioned, and that's clear. There, in some other presentation, they say that there is a high visual impact. There is a visual impact. That's clearly true. But we need to bear in mind that it would be mainly deployed in motorways where you have a huge traffic that are in the countryside, where you will have also, let's say, wind turbine or wind farm. So it should not be a hurdle really to deploy such kind of solutions. And another point is that thanks to the ERS trucks industry having some kind of, let's say, batteries inside, it's not also necessary to build everywhere these kind of catenary solutions along the complete journey of the road. We can afford to have gaps in places deemed too critical for an ERS installation. So we can manage that, and that's also a good point of that kind of solutions. It was also mentioned that it's creating obstacles alongside the road, and that's true. We are talking about safety and security, but we also have to bear in mind that in most of the major cities in the world, you have tramway system with catenary system that are deployed, where you have trucks, cars that are driving below those catenary system and without any major problem issue, because it was at the top beginning, it was designed with that regulations. So it's possible to accommodate safety and security regulation within thinking at the top beginning and working closely with the national road authorities to manage that. But there is solutions in front of each safety and security regulation that are specific to each countries, but can be managed. And the best demonstration is that it has been managed in Germany over real installation on real motorways. One of the side effects also that we can see is that this ERS system will participate to the development of the local economy. It will really stimulate the economy, the regional economy, because thanks to that kind of solution and the link that you will have and the business model that we can deploy around that kind of solutions, we can foresee a kind of development of the industry, platform multimodal, stuff like that. And it could be part of the different national recovery plan to accelerate the economic growth. If you can go to the next slide. Yeah, and the next point would be, okay, now we need to reach a certain size of ERS, so meaning that we'll have to deploy sooner than later, I would say, massive ERS installation. So we need to make sure that the industry is ready to deploy that right in time, and I would say on time, on budget. And because it's a well-proved technology that is coming from the railway business, we have a strong know-how, expertise, and that a lot of return of experience to calculate that cost, to be sure that we will be able to reach the milestones to deliver that and to maintain that. And because this kind of industry and the basis of this industry are already existing, there is the ability and the capability to deliver such a large scale project on time and budget at the end. So it's a very important point. And the last point is that the industrial sector is ready for this open and interoperable technology. And it's important because all major players in the railway industry would be able to go for it. So no customer would be bound to one single supplier. It's also a key point and an attractive point for that kind of solutions. And last, I think that it's important to mention that the technology for the trucks, so the pantograph, it's commercially available. So I mean, this upgrade on the trucks would be also possible. If you can go to the next slide, please. So from our point of view, we can see that there is a lot of studies all over on an international basis, but also in Europe. There is pilot project, and now we think that we need to go for the next step, that is really the national infrastructure network to be built, and to think about cross-border and regional development. That's important because obviously you need to have this interconnection between the different countries to make sure that a truck that is driving from, I don't know, from Sweden is going to Spain would be able to use more or less the same technology. So that's really important. And we can see that some of the countries like Germany has really moved quite far on that. The Bundesministerium für Verkehr und Digital Infrastruktur have really prepared a document, a deep analysis. So you have the link, and I really suggest you to look at that document to see what are the conclusion and what they are pushing in terms of technology, but only how they have managed this kind of study and how they have managed the technical choice. And we can see that there is a kind of a roadmap that is clearly defined in Germany around 3 major technologies. So the electrical vehicle, the fuel cell electrical vehicle, and catenary trucks. And they have announced that they are reach out for international partner, and they really clearly define a roadmap and some milestones to deploy that kind of solutions at a large scale, but also to make sure that there will be an impact on the CO2 emission. So that's, I think, of interest to see that there is countries that are moving on that. Can you go to the next slide?
Yeah, thank you very much. Now we've seen both the technical requirements, but also how one can easily implement an electric road system, or the preconditions for a large-scale international implementation of ERS. But then the third point, which is also crucial for assessing ERS, is will it attract users? Because without the users, it will not realize its economic or CO2 reducing potential. And there it's very helpful that there are lots of studies, some of them in German language, some of them other languages, but there are also a few reports in English language, looking both on the total TCO, which of course is the very important criteria before building anything to look at. But once it's built, it's also important to look at the marginal cost. And we see that because of the very high energy efficiency of electrical solutions, and then compared to other solutions such as synthetic fuels or hydrogen, there will be very strong incentives to use the system in operation. And therefore, it's very, very likely that you will have a high number of users who will want to use the system, and therefore it's a very clever way to realize the economic or the CO2 potential savings of the solution, and reaching that goal that we've set for ourselves, both in terms of very ambitious carbon reductions by 2030, but then reaching eventually a zero transport emissions or global emissions by 2050. And not only in Europe, but we want to have solutions that can spread globally. And therefore, it also becomes very important that we put money and investment into those solutions that have the greatest economic potential, and the strong efficiency advantages of the catenary system is here for the most important argument. And then we have our final slide. If we could go to that one. So just to summarize the key points, we see that a catenary solution allows the decarbonization of heavy road freight transport because it can be fitted on a tractor truck and deliver those power requirements and operational requirements that we see. It's also something that can be scaled up quickly because it's already built on, we already have experience of it, especially as catenary electric road, but also the basic technology is available through very broad supply chains. It is compatible with other solutions. We mentioned this in the very beginning, but we can also mention that some of the projects that we've already done, for instance, earlier demonstration projects in the US, we showed that we can combine a battery electric truck or a gas hybrid truck with the overhead contact line system. And the studies have shown this is a very, very economical system. And that combination, having the economics, having the economic scale, means that we can also reach the decarbonization goals, not just in one country, if it's Germany or Sweden, but it can also be deployed across Europe or globally. Catenary is not something that's unique to Europe. And therefore, we see that we have a very promising solution here to reach the goals that we see for ERS. Augustin, if
I can add a point. I mean, I think that we were a bit running out of time, but yeah, just adding the last point, because obviously ENGIE is also an energy provider, so it's interesting to see that ENGIE Group, so its name not really the same BU as mine, but is looking at that solution, because obviously there would be also some interesting business model to let's say to be part of the financing solution, but look at kind of green corporate PPA that you can place around this kind of infrastructure, and just to make sure that yes, you will be able then to provide green energy on a long time basis and to operate that. So let's say that there would be an interest also from energy providers to look at these kind of solutions to make sure that this ERS system would be directly linked to green energy supply. And I think that you can go to the next slide, and it was, yeah, thank you very much.
Exactly, and thank you, Augustin. It's been a pleasure preparing this together with you.
Yeah, thank you,
Patrick. Questions and discussions.
Thank you very much, both of you, for this very interesting presentation that we had from your side. And we can go further to our next speaker. So the next speaker for this afternoon is Karin Ebbinghaus, CEO of Electrified Sweden. Karin, I can see you. Please.
You see me and hear me? I will.
I'm hearing you, yes, perfectly.
Try to share my screen. I guess that would be the most common sentence in 2020. Can you see my screen?
Yes, and where is the link? And turn on your mic.
Yes.
Thank you, Karin. So the floor is yours.
Thank you so much. Really glad to be here. And it's been a long afternoon, so I want everyone to take a moment and close your eyes if you want, and picture a future that is fossil-free and you can drive with infinite range. Forget everything about range anxiety and think range happiness. So my name is Karin Ebbinghaus. I'm the CEO of Electrified, and we want to be part of a more sustainable and democratic approach to mobility. A bit more than 10 years ago, our founder, Dan Citrius, almost like a father figure to me, wanted to buy an EV, but thought they were too expensive, the range was too limited, and really difficult to find a place to charge living in a flat in a city. And driving to work one day could be in this time of year, snowing, not my kids making any sounds. So driving to work one day, a bit of a snow, and you know, it piles up in between the car tires. And Don was thinking, what if there was something there that I could charge my car on? A bit like the kart track I used to play with when I was a young kid. So he went home and sort of constructed the first prototype with his kids' Lego. As you see here, we have sort of saved it. And lucky for Dan and for us, we live in a university city, Lund, which has an excellent faculty of engineering. So he found himself a professor and a stellar research team that took this idea and turned it into a solid live project. And now we're here a bit more 10 years later, and I will take you through the highlights of Ers solution for electrical road systems. But before we jump into details about our technology, I would like to briefly touch upon how we see this electrical mobility transformation journey. And as you know, our long-term vision is to have a system supporting seamless transportation, a bit like a new internet for transporting people and goods. Let's call it a universal mobility. And I think that autonomous vehicles, digital platforms, and high utilizations of all our resources to minimize our carbon footprint is what we need to aim for. It sort of lingers in the horizon, not in a too far distance, but before we can dance, we need to take our first steps. And the first steps are increased awareness, switching into electrification of our vehicles, as we have started to see. And in our neighbor country, Norway, they have really started to dance. But as the number of EVs and both light and heavy vehicles are increasing, we need it to make it more convenient for the mass market to adopt. Automatic and convenient charging is the next step, and electrical roads will speed up the transition, being a bit like broadband or fiber has been for digitalization of our society at a large scale. So full utilization and uptime will be achieved for commercial fleets and heavy trucks first, and then we as private persons can just follow along once the infrastructure is there. Electrification in general will require a lot of us as a society. Electrical roads in particular requires cooperation of stakeholders that has not been forced to collaborate before. It's a new territory that raises a lot of questions and concerns. That's a natural process. For us, we see that we need to merge the energy, the automotive, and the road sector together to drive a more sustainable future, especially if we put a digital layer on top of it. We need to have smart systems that can balance peak loads, charge when we have an abundance of renewables, and we need to track and safeguard efficient traffic flows. And of course, electrification and ERS systems requires heavy investments in grid infrastructure and also new vehicles. But if we work smart, we can make the transition as sustainable and cost efficient as possible. Talking about sustainability and being cost efficient, a solution is only truly sustainable if it can also make economical sense. As a company, we're always thinking of how we can build a long-term profitable system that creates value for the relevant stakeholders. If we also consider the climate as a key stakeholder, investing today in order to mitigate the climate impact of transportation going forward, then ERS will be a brilliant solution. So enough about the vision. Let's get down to details. From the idea of a real-life car track, we have constructed a rail that's made out of recycled aluminium. As I mentioned, we have collaborated with the Lund University for almost 10 years and had a small track rail outside Lund for several years before building this large-scale project that we do in Lund. And it works like this. So when a vehicle runs over the rail, it will send an encrypted radio signal, which will be detected by the smartness in the rail. And if it's an authorized vehicle, the road will recognize it and will unlock the power distribution in very short segments of only 1 meter at a time. And our system is a conductive charging system. So it means that we need to have a physical contact between the vehicle and the rail. And that allows us to transfer up to 300 kilowatts with 97% efficiency. And our test has shown that we can have already transferred 160 kilowatts just a few weeks ago. And safety is, of course, of uttermost importance to us. So we have a lot of safety systems with PCB cards controlling all software, and also included a lot of IoT sensors. So we can measure temperature, moist shaking, and even having visual radar chips to see around the corner. And the black lids you see here, they give LED lights. So we can give visual indicators to other road users. And we have 2 different versions of our rail. The one you see here is our on top mounted version that you actually just glue on top of the asphalt. Then we will have the same principle, but we will submerge it into the asphalt. And then it will be on the same level as the remaining road. This means it goes really quick to install it. We installed this demo project for the first stretch is 400 meters long, and it took us only 5 or 6 hours to do the actual installation. Each rail is 10 meters, so it's a modular system, and you can start with as short as 10 meters, but you can build it as long as you want. we need to have a power station every kilometer to connect to the grid, but inside the rail, we have the power supply on both directions. So even if one 10-meter rail is not functioning, it will not disturb the power distribution for the remaining part. And we think it's a modular scalable system that you can use both for highways and in urban areas, since we only power 1 meter at a time and exactly underneath the vehicle, it will be safe to use in all different kinds of environments. As previous speakers has been talking about, we need the rail, but we also need receivers and something to affect inside the vehicle. Of course, we need the DC converter to charge the batteries, but we also have a lot of sensors overruling the security system that can automatically shut down power distribution if there's something underneath the vehicles. We can also use the sensors in the rail communicating with the vehicle to give more secure positioning to autonomous vehicles. And as previous speakers have said, it makes perfect sense if you have autonomous vehicles doing automatic charging, never having to stop still, and have high utilization and full operational freedom to be deployed. So from our perspective, it's really a combination of using the rail and the technology on board the vehicles together with the digital solutions that will be increasingly important. We will use real-time monitoring of both access control to see if it's an authorized vehicle to charge, but we also know exactly the vehicle identity and the amount of power that has been distributed. So actually, there is a billing system built into the software to be used in the rail. And also, at least here in the southern part of Sweden, sometimes there's a shortage of effect. So the system will know the amount of effect available to be distributed to the relevant vehicles using the rail at each relevant time. So actually, if we only have a certain amount of effect, it will be supplied to the vehicles that either needs it the most, who has the less battery capacity, or actually who has the highest willingness to pay. So it's a very flexible solution that you can adjust either to provide power or energy to red light or to blue light vehicles that need it, or for example, public transportation, if you need it for buses, and then you can reduce it for other uses. So you always have efficient powering of the vehicles you need it the most for. As I said, it's a modular platform technology, and we have projects actually together with DHL here in the southern part of Sweden to have a stationary opportunity charging. And they see that if you have a whole terminal full of different electrical vans, it will be convenient to use this system. And actually, I know it's not a scientific based study, but they have two different delivery vans standing beside each other, one with our system and the other van with a cord. And apparently the driver who uses our system is much happier at work because he doesn't have to use cords every day. So all he has to do is drive over the rail, stop the key, and charging will start. And then we can, through our software monitoring system, have control over the status of charging at all times. And we think the combination of charging when you stand still, but perhaps overnight charging, but refilling on the go, or if you stand still delivering goods somewhere, that will be the most efficient way to use charging in order to keep your battery levels down. And we can also see a problem with this whole electrification issue, that even if you can charge stationary overnight, it will put some restraint on different kind of property owners, because they will have to increase capacity in their buildings, and that is not done without a certain cost. And if that is the case for several, it will be more cost efficient to use a charging infrastructure during a day when you're on the go and share an infrastructure, electrical road system that is deployed for everyone. We think it's a more democratic way of looking into infrastructure. And this is one of the projects that we are doing. We are one of the 4 projects that the Swedish Traffic Authority is investigating. Really proud to be Swedish and of the Swedish Traffic Authority who tries different technologies and evaluate them for different perspectives. So we are part of this consortium. Even if we have developed the actual technology and supported by the Lund University, there are several stakeholders, both from the utility side, from the vehicle side, and from actually public transportation, looking into this, measuring, verifying our results, so we can present our reports end of 2022. But so far it's looking good. We have installed our first part and we're doing our submerged version within a few weeks. We're just waiting for a bit nicer weather. But so far the project has concluded, even if we of course are affected by COVID-19 as all of us. And coming back to why we are focusing so much on the climate, it's really important for us as individuals working here, as a company and as a technology, to have a positive climate impact. And when we look at, for example, Sweden and see the amount of batteries that would be used or needed if we were to electrify the entire vehicle fleet, and you see there, if we had fast charging, it works, but it requires a lot of batteries. And if you see for personal cars, it is the largest number, and the long haul trucks is not so much. So if we want to have this really positive climate impact, we need to have an infrastructure that addresses all kinds of EVs. Even if it's possible to do it with stationary charging and fast charging, if we want to really utilize our resources the best, we think it makes much more sense to have infrastructure that could be targeted to all kinds of vehicles. So what is our key takeaways from our process so far? Well, we can see that it goes really quick to install and it's easy to have maintenance on this kind of system. It's modular, so if one rail is not functioning, it's very easy to switch it out. And if you want to do road maintenance, you can just move the rail aside if it's a top margin, or just lift it up and do your restructuring and put it back again. And should you not want to have an electrical road anymore, it will be really easy to put back the asphalt. It's important to have an electrical road system adjusted for all kinds of EVs. We have so far tested our system on a personal car. It's our founder Don's car that we have been using. We also have a bus that goes in normal traffic as a trolley bus, but actually we use it to power it with our power strip. We can use it well, both in urban areas and in highways. So it's a very flexible system. You don't have to have one system for your long haul trucks on highways, but you can use it in urban areas, last mile delivery, and also standing still. It's fully digitalized and connected. That means you also can use it for autonomous vehicles. You can manage peak loads, and you can really have a smart system to use our resources the most climate efficient as we can. And as I said, it's future proof. So be prepared for, even if we don't have autonomous vehicles today, and probably not within the next year, but if we look in the crystal ball of 5-10 years ahead, I think there will be a lot of application areas, especially where you have quite repetitive transportation patterns. moving back and forward, then automatic or autonomous vehicles will be have an important place in our society. And we can also see that a digitalized electrical road really will increase road safety and have a lot of predictive machine learning of our transportation pattern, give signals, and we can learn a lot about how to monitor and have a more safe, secure, and sustainable transportation in the future. So thank you so much for now. Looking forward to all your questions.
Thank you, Karin, very much for your presentation. It was very interesting to hear all your developments that you have in Sweden. And now we are approaching to our last speaker. Today we have Ers, CEO and co-founder for Electron Israel. We can see you and we can hear you, so please share your screen with your presentation.
Yeah, I will share my screen.
And in the meantime, I would like to request all the speakers to consult the Google Doc that we shared with you to see your questions, because we have a real lot of questions. So you will have some minutes to prepare yourself before we will start Q&A just after our presentation. The floor is yours.
Hello, everyone, and thank you very much for the opportunity to be part of this webinar. A brief about Electron. Electron is a technology company in the field of wireless ERS. Very interesting that we see lots of conductive, but less wireless. We believe that it's, we can see in the world that there are lots of companies that offer a static charging, wireless static charging, but dynamic is very, very challenging. And we are very happy to achieve this goal. And I will show you in a minute a few projects with our technology. We have 5 projects in Europe and in Israel. We have 19 patents around the technology. We integrated our system on 3 new bus platforms, 1 electric truck, and in 2021, we will install our technology on 6 new different vehicles. So Electron provides a flexible and optimal solution, enabling 3 charging states. Of course, dynamic ERS, while electrifying the vehicle while the vehicle is driving. This technology is perfect match when we have a fixed routes, like city buses, point-to-point delivery trucks, and long-haul trucks. When the benefit is the fact that we can reduce the size of the battery, of course, we can eliminate the need to charge overnight, and of course, to operate 24/7. The second state is semi-dynamic, especially for taxis, when they stand still at the queue waiting for loading passengers, and they need the ability to move slowly in the line waiting for passengers. And of course, this is a perfect match for vans, as we heard before, when they are standing at the loading dock waiting for loading goods. And of course, in a city, it will be very, very complicated to install charging stations. So wireless charging is a good solution. And of course, static charging units for all types of vehicles. It's a huge benefit because they don't need to handle wires. So our system contains 3 main elements, as you see in the picture. We have copper coils that we installed 8 centimeters below the asphalt. Of course, it will be very easy to repave the asphalt, and there is no need to take out the coils. The second unit is a management unit that controls the section of the road. In this picture, you can see underground unit and above ground unit, both options. With the underground, there is a huge benefit because nothing is visible. And of course, the third element is a receiver that we installed at the bottom of the truck. And of course, we can connect it easily to the battery. And of course, 2020 was a very, very challenging year when we deployed 2.3 kilometers of road in both locations, in Israel and in Sweden. It was very challenging, different location, different climate. In one hand, we have 40 degrees, and in Sweden, we have a heavy snow. Of course, we deployed over 25 management units, some underground, some above ground, and one static unit. We integrated the receiver units in 3 different bus platforms. The first one is a Higer bus equipped with supercap technology, 42 kilowatt hour. The second one is a Higer battery electric bus equipped with 210 kilowatt hour battery. And the third one is articulated bus equipped with 518 kilowatt hour battery. And of course, we have a long-haul truck in Sweden from EFORCE equipped with 210 kilowatt hour battery. And what is unique with our technology is that we are agnostic to the storage inside the vehicle. We can connect it easily to a supercap or to a battery with a battery with 300 volt voltage level up to 800 volt battery without the need to change the battery or the vehicle. And of course, we are not doing it alone. We are doing it with our global partners. So I would like to share with you a short video about the deployment in Sweden. And of course, the maintenance is minimum due to the fact that all the system is underground, so nothing is visible. And there is no safety issues because all the equipment is under the asphalt. And of course, we gained a lot of knowledge after we deployed 1.65 kilometers of road in Sweden. And in Israel, we completed almost 1 kilometer of road within 1 day, and I will show you a short clip. Okay, so in 2018, actually, this is the year that we started our journey with the Swedish Road Administration. We had a proof of concept with a private vehicle when we transmitted around 11 kilowatt. But in 2020, we increased the energy up to 25 kilowatt. And of course, we have on the truck, we have 5 receivers, so we can reach up to 125 kilowatt. And with our buses, when we have 3 receivers, we can reach up to 75 kilowatt. And in 2021, we will increase the energy to 35 kilowatt per 1 receiver unit. And the goal is to reach 45 kilowatt in 2022. There is no limit to transmit energy over the air, but the reason is to find the optimal solution, not the highest power, in order to not to change the environment and to meet the power level for the vehicle. As you see, we have connected the system to a normal grid connection, 400 volt, 3 phases. But in 2021, we plan to increase the voltage level up to 550 volt, 3 phases, AC of course, and 800 volt DC. This will allow us to increase the energy in the given system without even changing anything at the vehicle side or at the road side. Regarding the speed, we tested the truck in Sweden under heavy snow up to 60 kilometers per hour, and we plan to test it this year at a speed of 80, when the goal is to check the system under 100 kilometers per hour. There is no limit in speed, as we see in our simulation and even in our road tests. So I would like to share with you some takeaways and insights from our project in Tel Aviv, Sweden, and very soon in Germany. I will start with the project in Tel Aviv. The city of Tel Aviv has a plan to electrify all the buses in the city. There are 1,300 buses driving on a daily basis inside the city of Tel Aviv, and it will be a huge benefit to electrify the road in Tel Aviv and to reduce those batteries and to remove the need to have charging station at the depot, of course, and to open the service 24/7 for the citizens, of course. This is why we chose to start with public transportation, and this is our bus equipped with 42 kilowatt-hour supercapacitor, and we are going to show that this bus can drive 24/7 with this small supercapacitor. We chose 2.3 kilometer of road under the university in Tel Aviv, and we paved around a bit less than 1 kilometer of road, and this bus will drive 24/7 in this route. There is no need to plug this vehicle to any conductive charging stations. And what is very interesting to share that in urban environment, there is a need to collaborate and coordinate with a lot of companies that already have infrastructure under the road or at the side of the road. And the fact that in our technology, there is no physical connection between the road sections. Every section is independent. And of course, we can, just a second. And of course that we can change it, and it's very flexible. We can start with a section of 40 meters up to 100 meters, and this flexibility gives also flexibility to coordinate to accelerate the coordination process with all the players, which is very simple and very fast. And of course, in the Tel Aviv test case, we utilized the existing grid connection along the route, which made it easier and cheapest. So we don't need to build or to create a new connection to this road and feed this road. The project in Sweden, we chose Gotland, Gotland Island, and of course we are going to we are showing and driving this truck already about a month. We paved 1.65 kilometer between the city of Visby to the airport. This is a 4.5 kilometer stretch, and we paved 1.65 kilometer of road. We have high-speed section and we have a low-speed section to test and to show all aspects. We are showing a truck and a bus driving on the same road. In this project, it was very, very interesting to show how easy is to integrate a receiver on an existing vehicle. There is no need to change anything at the vehicle side. There is only two connectors that we need to plug in and to connect it to the battery. We have on this truck 5 receivers, and the connection is very, very simple. Also, in this project, we have a renewable energy that we can feed to a section of a road, so we can show a holistic solution when in one hand we harvest the energy from renewable and we can feed it to directly to the road. And of course, the third project is a project that we are going to carry out next month in Germany, together with EnBW, a utility company in Germany, a good partners. We are going to show a shuttle for their employees in Karlsruhe, a shuttle that will be based only on wireless charging. We are going to have a mix between a dynamic stretch, a semi-dynamic, and a static. And this bus, equipped with 210 kilowatt-hour battery, will be charged only from wireless charging. And in this project, we can show that there is no need to electrify all the route. We can have a stretch, and with the right operation, we don't need to pave the entire route. So our main activities for 2021, the first one is standardization. It's very, very important to have standard. As there is already a standard for charging, wireless charging, static wireless charging, and right now we are helping Professor Yul from KAIST and WePower1 to build the dynamic wireless charging, the standard for dynamic wireless charging. Of course, we will take active part in this standardization committee. We will have to define the road construction that is needed in order to electrify heavy-duty vehicle. And a very, very important part is the communication. We are going to push to adopt the OCPP protocol that already been used for existing charging system across the globe, and it will be a huge benefit to connect the wireless ERS to the existing charging systems. Of course, we are going to focus, as I mentioned before, on 3 main parts: urban buses, point-to-point delivery trucks and long-haul trucks, and taxis and vans that are waiting at the queue. This will be the first section that we are going to focus on. And of course, we are going to collaborate with more OEMs in order to spread the technology for an enable market entry. This year, we plan to start more projects and to enter the US market. We are working on a sufficient project in US, and we will be able to unveil it in a couple of months together with very strong partners. And it's going to be a very good beginning to start collaborating with US companies. We are going to start very soon a project through the BUST, the German Federal Highway Research Institute, together with Eurovia from the Vinci Group and Volkswagen. We are going to demonstrate a section of a road dynamic ERS on eCrafter from Volkswagen. We're going to test the effect of our coils on the asphalt and to test the receiver or maybe two receivers on the eCrafter. And we will start it in a few days. And there is another very, very interesting market in Italy. Berbemi, together with the Politecnico di Milano, completed the first study about regarding ERS, and they decided to start with as the first project with inductive charging, and we hope to take part in this project. So it will be very, very interesting for us because it's a toll road, and we will be able to test vehicles in a high speed. Thank you very much. We'll be very happy to answer questions.
Thank you very much, Oren, for your presentation. You can stop sharing your screen. So we'll come back to the view of all the participants. In the top of the screen, there is stop share. Yeah, excellent. Perfect. Thank you very much. Thank you to all our speakers. We just finished this part of the webinar where we have the speakers. I would like to now start the second poll for all of you. If I may just open it. Okay, so please respond to this poll. I think it will be interesting to all of us. And if you have this kind of ERS case studies, you can always contact us by email to the PIARC address or to Miguel or mine address. That would be very, very helpful for us for future works of the task force and for any other group that is combined with this topic. I will just open this poll for a while, so all of you, I hope we will have the possibility to respond on it. And I saw once again a question regarding the recording for the of this event. So yes, it will be available, and it will be available on our website, PIARC website, and in the same time in the YouTube channel of PIARC. So in a few days, whenever the file will be ready, we will upload it. And for sure you can connect and to see the webinar once again. So now we would like to move to the second part of our webinar today. So Q&A. We have lots of questions, so I would like to ask Miguel to join us. Yes, we can
hello.
See.
Hello, Alexandra, and hello, everyone.
The floor is yours for this part.
Thank you very much, Alexandra. Well, first of all, a big thanks to all the speakers for their excellent presentations today, which I'm sure have helped and will help road infrastructure and road transport professionals to learn more about electric road systems. But I also want to thank them for keeping the time for the presentations. You had a lot of things to present, and we asked you to be concise, and you managed to keep the time. So thank you very much for that, because it allows us now to have time for this Q&A, which we are very much looking forward. And after those thanks, I also want to thank all the participants, because you have made a lot of interesting questions. I have noted over 30 questions, specific questions process. I don't think we will have the time to go to all of them, but we will try to go to a maximum number of them. And I will discuss with speakers to see if we can provide a written answer over the next weeks through our webpage. So I'll link it to this material that we put on the webpage. Okay, so now we'll go for the Q&A. I invite all the speakers and also some representatives of the task force to join us and to switch on their cameras. And in order to address a maximum number of the questions, I really ask all the speakers and panelists to try to answer in 1 minute. I know it's very complicated and very challenging, but I hope we can keep the time. Okay, so let's go to the first question. And if you have more, please note it on the chat. I'm not sure we'll have the time to go through them, but we will try to give them an answer on the next days. I'm gonna stop sharing now. I invite you to switch on your cameras. And I'm gonna go for the first question, which is an open question to anyone, any of the panelists who wants to answer. And it comes from Colin Ingram, and it says, construction is a big producer of CO2. Has any research been done to investigate how much CO2 is generated in the installation of electric road systems and how long it would take for a break-even CO2 generated by adding area systems to the infrastructure and by the CO2 that they will save? Has any of the panelists have a figure, a number on that? I think Patrick Ackermann, maybe?
So I don't have the figure on top of my mind, but I know that there was a study, actually there are two studies. The one was by the German Transport Ministry, looked at the life cycle cost and impact also CO2 from the infrastructure. And it's actually the smallest part of the whole system. So the impact on the vehicle side and the fuel consumption is much greater. And there was a study by Chalmers University. And there, I think the number was about, because they looked at a mining application. So they would have just a couple of mining trucks using the system. But even with such few vehicles using the system, because the energy consumption, the savings are so big, there was a payback in terms of CO2 within just a couple of months. So I think the infrastructure aspect is, of course, important, but from a CO2 perspective, negligible.
Thank you very much. Yeah, so it confirms the big CO2 emissions in the road infrastructure is the vehicles, is not really the infrastructure. Let's go to
add,
yeah, sure.
add this question that in wireless charging case, we can use the time that they repave the road and to use this this timing to install the coils, so there is no extra work needed.
Thank you so much, Oren, for that precision. Let's move to the next question. This is a question for Patrick Duprat, and it comes from Hervé Etave. And it says, how many electrical substations are required by Kilometer, especially in rural areas? Patrick, please.
Yes. First, this type of system is mainly for main road with a high, with a lot of traffic, not really for rural, not for rural road. And on highway, we plan to have one traction power substation every kilometer. After we will in shelter, and we will put the power needed according to the traffic on this corridor.
Thank you so much, Patrick, for that quick answer. Next question is for Mr. Tajima-san, and it comes from Bernard Jacob from Université Gustave Eiffel in France, but also link it with a question from Adriano Ferreira from Intraf. So the question is, what happens if there is a pedestrian, a cyclist, or an animal at night or on the emergency line?
Yes,
Tajima-san, please.
Yes. Our system will add on detect infrared sensor. Infrared sensor. We detect each 100 meters point. We add on infrared sensor for protect safety for house, for example, and same sensor. That sensor is infrared sensor. We add on, and we had a fuse and breaker. We had our infrastructure system had a breaker and fuse. And before I detect infrared, we use infrared sensor. We can detect animal and human being, and so on.
And I guess once you have detected, you remove the branch to connect to the rail. That's what happens once you detect. Do you stop the car, or do you take out the connection, or what do you do?
Yeah, we stop the, we detect animal or human beings touch after we suddenly stop the infrastructure power. And in the car, in the car side, stop the dynamic charging system. We can control.
Thank you very much, Tajima-san.
Yeah,
let's move to the next question. This is a question for Josefin Aderell, and it comes from Doros, UK. So, is the EVIA system fundamentally different to other in-road solutions, for instance, Alstom systems? Do you see any in-road electric road systems as the most promising approach for a cross-border electric road systems?
So actually, when we started working with this, the in-road was the last on our list. So we looked at all the others over Ers Solution and also Conductive. And by testing and by conclusion, we arrived at the in-road solution was the best solution. So hence we started the development. We have been developing this for a very, very long time, and also extensive testing, both on test tracks in Sweden and on public road 2 kilometers in Sweden. So we believe that we have a very robust and safe system that is ready to be commercialized, more or less. I mean, fine tuning also, of course. So that's my side.
Thank you very much, Josefin. Let's move to next question. This question is for Patrick Ackerman and Augustin, Siemens and Engie, and it comes from Hervé Stav and says, what is the business model? How do you invoice the consumption of energy?
So can you hear me? Yes, so there, of course, the easiest way is to measure the energy in terms of kilowatt hours consumed. But you can open up different kinds of possibilities to how to bill for this. You can charge, have a fee per kilowatt if that's more related to the power company. You could also charge per kilometer that you drive. That would also link it up with how tolling fees are currently collected in much of Europe. You have an European electronic tolling system. So all the trucks that are driving, especially this is about trucks, the tractor trucks, they have an onboard device that measures where they're going and what toll fee should they pay. And with the upcoming proposed European regulation on Eurovignette directive, they have to indicate, are they going in zero emission mode or not? So they need to send this signal, am I electric, am I not? And with that information, we can also build them. And I answered this question also in the chat because there was a working paper on business models that was published in November. And I would recommend everybody to look at it, how business models for European ERS could be done. Thank you.
Thank you very much, Patrick. Augustin, anything to add? Is it good?
No, that's perfect. I mean, we are working also on the connectivity subject with some 5G solutions to deploy across the highway, just to make sure that there is this connectivity. But I would say he has answered correctly to the question, so that's fine.
Thank you very much. Let's move to the next question. It goes from Karim, and it comes from Bernard Suivigny. Have the rails been tested for durability with regards to to freeze, thaw, salting, snowflakes? What happens when resurfacing surface dressing is required? Are they essentially removed and replaced during the works?
Yes, so the on-top mounted version has been out for some years and tested with the snow and salt and has shown a robust test for that. And actually, we were out today with our snow plow and removing snow because we had some snowfall overnight. So that works well. And for the submerged version, we are installing that in a few weeks. So, but that will be in the same level, and snow plowing will not be a problem. And then we also have heating within, so we can de-ice it, and our temperature sensors will let us know when it's a good time to do that, because we don't want to waste energy if not necessary. And when it comes to refurbishing the asphalt, I mean, if you have the on-top mounted version, you can just move it aside and put back the asphalt. And actually the submerged version, it's constructed in two sections. So it's an outer box, and then you have the expensive rail within that. So you can actually just remove the expensive part and take out the outer box, and then you do the re-asphalting again. So it shouldn't be a problem. And changing one 10-meter section will take a few minutes.
Great. Thank you very much, Karin, for that answer. Next question is for Oren, and it says, which could be the inconvenience of the underground solution? What is the charging yield? Do you estimate some losses in the charging intensity between the underground solution and the direct contact one?
Actually, it's very interesting. We are measuring the efficiency between the grid connection to the battery. This is what we measure when we talk about efficiency, not just the transmission of energy over the air. In static mode, we can measure up to 93% efficiency. In dynamic, while it's the coupling is changing, the average is around 87, 88%, again, from the grid connection to the battery. This is the efficiency that we are measuring. There is no losses, special losses by transmitting energy over the air if you compare it to conductive.
Thank you very much, Oren. Next question is a general question to all of you, and it comes from Cameron Root and says, do any of the speakers have any available data regarding the cost of electric road system technologies, in particular to the cost of maintaining the system? So not so much installation, but a maintaining cost. Josefin, do you want to answer first?
Yes, so the maintaining cost should be below 10% of the investment cost for our solution. And looking at an economic lifetime of 20 years, the maintenance cost will then be under 5,000 euro per year and kilometer.
Okay, thank you very much, Josefin. Patrick, do you want to complement?
So we, of course, have ample experience from overhead contact line systems, and there the maintenance cost is around 1 or 2% of the capital investment.
Perfect. Thank you, Patrick. We don't, since you told us you don't see your image, we don't see your image anymore, but it's okay.
Also,
anyone wants to add anything?
With our system, the maintenance is minimum because there is no need to. First, everything is underground, so there is no way to damage the system. So the maintenance is very, very minimum, less than 1%.
Thank you very much, Oren. Anyone else? We're good? Okay, let's move to the next question. So next question is a question for three of you, for Alstom, EVS, and Elon Road. And it says, all these systems have very similar functionality, but are obviously incompatible with each other. Which one should we pick up and why? And choosing on one will automatically put the other ones out of the picture. Any thoughts? So please just answer on the.
Perhaps start. I think we complement each other well, and we are part of the same standard group committee to investigate further. And I think it's really good that we are trying these different technologies, and perhaps we will find out the best version and use that. But for some time, we can have different road technology and we can have adapters on. I think we can still use each other's system to some extent.
Thank you very much. Patrick, Josefin?
On my side, maybe I would say our system, maybe the difference is the type of applications. In our case, we plan to use this system really for highway, to decarbonize long distance. So with a lot of traffic, the other two solutions are maybe more for cities. I don't know.
Thank you, Patrick. Josefin, anything to add?
Just to add on upon Patrick's comment. So our system is for all types of different societies and also solutions. So everything from mining to station-based to on the road and also on highways. So preparing for tomorrow's society. Thanks.
Thank you very much. Next question goes to Patrick Ackerman from Ruan Barbreda, Sunral, South Africa. What kind of modifications have you made? have had to be made to trucks to use your catenary electric road systems solutions. What are the cost implications on this additional weight added to the trucks?
So if I start backwards, maybe you can see me now. I still don't see myself, but I clicked the button. So the pantograph system itself is about 350 kilograms. And given the, what do you call it, the degradation of the limits on how much weight a truck can have if it's a clean vehicle, we don't affect the payload. So it's very important that we with the tractor trucks, we have the same flexibility and same payload capability with the system. Now, what things need to be changed? Well, we have to then put a little tower at the back, but it's within the space, about 50 centimeters wide, that fits behind the tractor trailer. And you need to have a base plate that sort of integrates it, but that's something that can be done on all truck types. In terms of cost type, this of course depends on the volumes that we would expect. We saw in the previous slides that we have about expected to have 22 trucks up and running in Germany by the end of the year or so. So there's still room to have more volumes, and then of course prices will come down. And if we look at just a simple comparison with what pantographs costs in other applications, railway or tram lines, then a typical pantograph there costs about 7,000 to 10,000 euros. And of course, these pantographs for trucks will be a bit more complicated, but the volumes that we expect of the truck market will be much bigger than on the railway side. So that's also where we expect the long-term price for these components to be.
Thank you, Patrick. Yeah, sure you did. And we will jump in that question of business model and potential subsidies, help to haulers, etc., over the next webinar of PIARC on business model for electric road systems. Sorry. Let's move to the next question. It is for Karin Ebbinghaus, and it comes from Peilin San. And it says, if there is any obstacles like a small rocks on the rail and it's propelled by the pickup device, can the obstacles get off the road and hit over the vehicle people's nearby? Karin, do you have any?
Yeah, so our first test part has been on a quite heavy polluted area. It's close to a sawmill, so it has been a lot of objects lying around. But the sliding contacts which we have, they are very light with a feather. So if they touch an object, they will sort of go up again. So it's not a solid piece of iron that goes down. So it will adjust itself more to the objects on there. So what we have seen, it's not worse or better than what happens when you drive over with your tires.
Thank you very much, Karin. Next question is for Oren and says, how critical is vehicle positioning alignment with the lane to ensure maximum energy transfer? Have you tested the tolerances?
Yes, of course. First, I think that it's for all types of technologies. We investigated the wandering effect for trucks, and we understand that the truck mainly goes 20 centimeters left and right. So in our case, it will be able to drive 30 centimeters each side. So all in all, 60 centimeters, and to reach the same energy and the same efficiency.
Thank you very much, Oren. Okay, next question is for all panelists, and I will invite also task force members to answer if they want. It comes from Henry Chua in the UK and says, for countries with high fuel tax, most of the European countries, fuel cost comparisons should be treated with extreme care. Why should electricity fuel not be taxed? Any thoughts on that one? Anyone? Patrick Ackerman, maybe? Patrick, we don't hear you, we don't see you. Josefin, please.
Well, electricity is already taxed, for one, to start. And also, I think that different governments are looking at different options of kilometer taxes on vehicles in general instead of taxes on fuels in the future. So there will probably be different schemes depending on the countries.
Thank you, Josefin. Patrick Duprat, do you want to add anything?
I think it's not to us to decide. It's it's authorities to decide this, but I think it will start with some bonus and malus. We will put malus on diesel, and when we will remove totally diesel, maybe tax will come on electricity. We will see.
Yes, we will see.
It's related. Yeah. Everything we can agree that the electrification of vehicles is happening. So it doesn't really care if it's ERS or if it's fast charging or conductive charging or overnight charging. So it's something that's happening already. So I believe it will be vary between different places, different countries.
Exactly. Thank you very much. Yes, I think it's a very strategic decision, and we'll see where we go. Let me remind you that France, the place where I live, tax fuels today are 33 billion euros, and investment in the whole road sector is 13 billion euros. So road users are paying much more than what they are consuming. And maybe a few decades ago, when road users were wealthy people, well, maybe we could say, okay, these people could pay for other taxes, or for taxes for other ones. Now we have to decide what kind of society and how to cost it in the future. But yeah, definitely a very interesting question. Let's see. Next question, it's an open question again from all of you. Please feel free to chip in. It comes from Lionel Beauty and says, what additional electricity production is needed in Europe for all these electric road systems? And which source of energy? Maybe Augustin, since it's an energy discussion, you can jump in.
Yeah, I would say, even if I am not an expert in that field, I would say regarding the way to give consumption figures, even per countries, I would be a bit struggling to find that. But I would say that there is some study that has been done in Europe. So I mean, at a later stage, we can provide some kind of link with the different studies. But generally speaking, I would say that the demand for electricity would be more or less a bit more, but more or less the same between, let's say, static charging stations and dynamic recharging. So meaning that at the end, we are going for electrical cars, electrical trucks, and so on. So it would have more or less the same impact, generally speaking. So at the end, this remains to be taken into consideration to meet our CO2 reduction commitment. And that's the main point. And just for your information, because we are always talking about the grid that will provide that, but there is also solutions to install, let's say, solar panels, wind farms, stuff like that. And you can link to the grid. You can add some now energy storage solutions. There is some experimentation in France, but not only, there is also in Germany. And that's allow the grid, or I mean, that's allow us to store the production excess of the renewable energy and to re-inject that into the network during a consumption peak. So I would say that it would be a mix of solutions. Yeah.
May I jump in there to add one thing?
Yeah.
Sure.
So there was a study in Germany looking at the total energy consumption, of course, of the whole German electricity system, which is about 500 terawatt hours, and adding all the electric trucks to that would be 25 terawatt hours. So it's about a 5% increase, but this will be spread out over maybe 1 or 2 decades, and that kind of increase is something that the grid easily can manage. And it's also not just a challenge about, or an issue about the energy, but also the power. So how is this located in time and space? And there, I think the advantage for all ERS solutions is that it doesn't have a punctual load. It's not lots of trucks coming at lunchtime in one spot in the grid, but it's spread out along the highways. And that makes it easier for the electricity companies to integrate it and supply it.
Thank you, Patrick. I forgot some previous questions, so I go back to the 13. Tajima-san, yes, please, go ahead. Please switch on your microphone.
Thank you. I think ERS system is ERS system need strong energy, strong capacity energy. ERS system must acceptable many kinds of energy system. One is from grid. Another one is energy storage. energy storage system must need are supplied by renewable energy. For example, wind power and so on. And one is from hydrogen. Hydrogen in Japan, hydrogen power is very important power energy from for infrastructure. I think ERS system is very important thing is ERS system can be accepted from every power supply system method. I think flexible, yeah.
Thank you very much, Tajima-san. Let's move to question number 13 that I forgot to mention before. And it goes precisely to you, Mr. Tajima, and it comes from Peliang Sub. And it says, does the roadside conductive solution have a very strong requirement on the road condition, road evenness, road gradient within road? And this solution seems to have a longer energized section. How will the safety be guaranteed?
Our ERS lane is each 100 meters. Each 100 meters per supply each, and but we don't need a segment power supply. But one section is one dynamic charging lane section length is 100 meters by each power supply. And our side system height is next month. I will show you small our ERS infrastructure. Height is about 400 millimeters. This one, and very small. And our conductor rail area is very narrow. I think our power supply system needs each 100 meters. I think a very safe system. And we can add on top of conductor rail roof. We can protect snow and rain and window and so on. Our system, our side system is suitable for many types of environment. Yeah.
Thank you very much. Let's move to the next question. It goes for Patrick Duprat from Kingji in Ashto, USA. And it says, was the system test for road debris impacts, especially when the contact shoe is deployed?
Yes, for this, we are testing some smart sensor to detect the biggest debris. In this case, we detect the debris and we lift quickly the pickup to avoid the shocks. And for small debris, it will have no impact. It will be like pushing by the tires. It's not. It has not impact. So it is. The testing is ongoing. Yes.
Thank you very much, Patrick. Next question for Josefin from Efrain Vallejo. Where do you use this system? And I guess it means what kind of road, street, etc.
Yes, so today we have on our demonstration road is a 2-kilometer road next to outside of Stockholm, Arlanda. It's a public road where you can drive around 70 kilometers per hour, but we also have a test track where we can drive faster than that. And the station based is also in the nearby area. So that is what we have today.
Thank you very much. Next question is for Karin, and it comes from Cameron Root and says, how to avoid the common issues of reflective cracking of road-bound electric road system technologies?
Yes, so for the mounted version, that really doesn't matter. But for the submerged, it's just really the top layer, and our solution is very robust, so it will handle it. And the shaking sensors that we have included will also sort of give us indication if something has happened and if there will be out of bounds, so to say. So we don't see that as a problem.
Thank you very much, Karin. Next question is for Mr. Tajima, and it comes from Doros Nicolaides, TRL UK. Can you use this technology when multiple lanes in a motorway need to be equipped with electric road systems?
A motorway, our side system is, I think our system add-on highway, only highway, because our system is high power. High power charging is can be very short time charging, and our system add-on center line lane. If there are in Japan is left lane car running, and we will be add-on center. One thing, one idea is center line, and another one is outside lane. I think if the vehicle must need charging center lane, and if the vehicle must need charging center line lane or outside lane, I think it's no problem system, I think.
Thank you very much. We are running out of time. I propose to take 5 more minutes to go through 3 more questions. So the last 3 questions, first one goes for Patrick Duprat and comes from James Gilbert in Indura, and says, what about the road noise generated? Has it been measured?
Not really, because when we make a demonstration in Sweden, in fact, the noise of the sliding shoes is covered by the noise of the tires. But on the coming project, we plan to try to measure it, but it's not easy.
Thank you very much, Patrick. One more question for Patrick Ackerman. In all electric road solutions, the truck fleet is more concentrated on a specific area of the road. Will this shorten the lifespan of the parts of the roads? Because Siemens has more tests on real conditions. I would like to hear from Siemens.
Yeah, I don't know if I fully understand the question, because we don't change the truck traffic. We just assume that the truck traffic takes place as it does today, and we upgrade existing roads. So if the highways can today cope with that truck traffic, then it can also cope with that truck traffic in the future, because our system doesn't change anything in the road surface.
Okay, yeah. I think it means in which lane of the motorway. That's the way I understand the question, but I think...
Okay, so okay. There has been some experience there. They looked, because the people wondering, will trucks change the lanes or drive differently? But there's been no detectable difference in truck traffic or car traffic on this highways where we've installed the highway.
Thank you very much. So we will take a last question, and we will try to answer all the other ones by written means in our webpage. And it's open to all the speakers, and it comes from Subikter Ubi, and it says, all these methods change the relationships between the vehicle and the road, and so has become more than the wheels and the tires. So what additional risk is there being introduced by such systems? Would this increase incidents due to incorrect use or failure? Jan Pedersen, do you want to go for it, or will we leave to the...
Well, I can say we have done tests with 4 different techniques in Sweden, and we have seen no effects on the safety issue regarding any one of these techniques. But of course, we will continue to follow that question. It's a very important question. But so far, we have not seen any big issues regarding safety.
Thank you, Jan. Anyone else? Oren, please.
Yeah, I will elaborate that in our case, there is no moving parts, no noise, no impact, no contact between the vehicle and the road. So actually it's a normal road. You can drive like before without knowing that not something is happening. And if you have a bump, actually we are driving in Sweden with the snow and we don't need to take out the snow. We can just driving on the snow and we will receive the energy. So you don't need to change the behavior of the driver. This is a huge benefit with wireless. And actually you don't see it, so you don't understand that something is happening.
From our side, we have LED lights and can give signals to different other road users. So I mean, electrical cars are quiet, so it can give like a heads up that there's coming someone, or it can give notification if you're speeding. Then the green light will turn red, or if you're driving too close. I mean, people are not really taking, especially now in winter, keeping the distances between the vehicles. So it can actually be used for road safety and not increasing.
Thank you very much, Karin. Okay, thank you to all participants. Thank you to everyone who make a very interesting question. We're going to stop now the Q&A, but we'll try to provide answers to the other questions that we didn't have the time to address. Before giving the floor to Jan Pedersen for the closing remarks, we have 2 more questions for everyone, 2 polls for this seminar, about this seminar. How do you rate it? Maybe it will help us for the future. So please don't be shy and rate it the way you want. Okay, a few more seconds. We'll leave it 20 more seconds, up to 1 minute, and then we will close this survey. And thank you very much for answering. And if you have any further comments or remarks, please send it to our info address, or info@piarc.org, and we will be happy to address it. Okay, I think we can close this one and go for the next one. Here are the results. Thank you very much. And this is the last one. So we are planning to do 2 more webinars dedicated to electric road systems, one in March, one in April. And they will probably be devoted to business model and to policy making. So if you could please give us a head up about your interest for those electric road systems, it will be very useful. Okay, 10 more seconds, and maybe we can close it up. Okay, thank you so much for answering. And I hand over the floor to Jan Pedersen. Jan, please.
Thank you, Miguel. Well, apart from being the chair of this interesting task force, I also work as a program director for how to electrify the state roads in Sweden. And we have just, for a couple of weeks, delivered a plan to the Swedish government how to deploy 2,400 kilometers of electrified road system by 2037 in Sweden. And of course, the government asked me and my colleagues, what are the challenges? Okay, I answered there are a lot of challenges, of course, but one challenge are we really secure will be solved. And that is the challenge, will there be any mature electrified road systems to use. And I think after these presentations we have heard today, I am so convinced that we have delivered the right answer to our government. Yes, absolutely. We will have a number of mature electrified road systems to deploy because there are so many professional industries that are working with these issues right now. So I think that is great, absolutely. But of course, to deploy ERS road systems, you need to have all the stakeholders on board. For instance, grid owners, the users, the road owners, etc., the vehicle manufacturers also. So that is why we are now promoting also that we will launch a number of workshops. This is the first workshop that we have conducted today in a series. So for the next workshop, we will more discuss about business models and with other stakeholders and so on. So we will invite vehicle manufacturers, users, also people from transport administration and ministries, because we also want to learn about national policies and strategies regarding this. So hopefully you will see this on PIARC website quite soon, so keep track on that information. But I would like to close this seminar now by thanking Miguel and Alexander for hosting this webinar and guiding us through these interesting presentations. Big thanks, Miguel and Alexandra. And also very big thanks to all the presentator and also the entire audience. And you have been really active in raising good questions, absolutely. And of course, we will display all the presentations and so on the PIARC website. So by that, I would really like to thank all of you and hope to see you again quite soon for the other webinars. So take care and see you again. Thank you all. Bye-bye.